Hello, hi students. Welcome to my channel. Today we are going to discuss previous year NEET questions from dual nature of matter and electromagnetic waves chapter. Our first question is, for a plane electromagnetic wave propagating in x direction, which one of the following combination gives the correct possible direction of electric field and magnetic field respectively? Okay, so what is he saying? He's saying that you consider a electromagnetic wave which is propagating along x direction. Now, for that electromagnetic wave, which of the following represents the electric field vector and magnetic field vector? Okay, so what did he give? He told that electromagnetic wave is propagating along x direction. Okay, according to properties of electromagnetic waves, we know that the direction of vibration of E bar and the direction of vibration of B bar will be perpendicular, and this E bar and B bar will be perpendicular to the direction of propagation. Okay, so E bar and B bar will be perpendicular to the direction of propagation. Okay, and now he told that the direction of propagation is along x-axis, that is along I cap. Okay, if you take I cap as the unit vector along x-axis, so the direction of propagation is along I cap, and this E bar and B bar should be perpendicular to x-axis. That means E bar and B bar should not consist of I cap unit vector. Okay, if you see options, all four options doesn't consist of I cap. Okay, next thing, E bar and B bar are perpendicular. That means the dot product of E bar and B bar should not be equal to 0, and the cross product of E bar and B bar should be along the direction of propagation. That means that is I cap. That is, this E bar cross B bar should be some number into I cap. Okay, now if you see the options, in second option it is clear that these two vectors are parallel. So this will not be the option. Okay. Similarly, in third option, these two vectors, that is, it may be E bar or B bar, whatever it may be, these two are anti-parallel. So this will not be answer. Okay. Similarly, in fourth option also, E bar and B bar are parallel. So fourth option is also not the correct answer. Okay. So the only correct answer maybe is first option. Okay. Now let us see whether first option is correct or wrong. Okay. For that, we have to calculate the cross product of E bar and B bar. Okay. Now let us calculate the cross product of E bar and B bar. That is minus J cap plus K cap cross minus J cap minus K cap. Okay. So this cross product should give a number multiplied by I cap. Okay. If that happens, then we can say that this is the correct answer. Okay, now so minus J cap into minus J cap cross J cap, that is 0, minus J cap minus K cap, that is plus J cap cross K cap will be I cap plus K cap cross minus J cap, that is minus of K cap cross J cap, that will be that is reverse direction, no? So that is minus of minus I cap plus, okay, K cap cross K cap minus K cap, that is 0. So minus into minus plus, that is I cap plus I cap, that is equal to 2 I cap. So that means you got, that is E bar cross B bar direction is along the direction of I cap, that is along the direction of x direction. Okay, x axis. So our answer is first option. Now let us move to our next question. Now, okay, 1 minute, wait. Okay. So now let us go to our next question. What did he give? The number of photons per second on an average emitted by a source of monochromatic light of wavelength 600 nanometers when it delivers a power of 3.3 into 10 power minus 3 watt will be. Okay. He gave the value of H. Now let us see what he gave. He told that you have a he has a monochromatic source which produces light of wavelength lambda is equal to 600 nanometers. Okay, 600 nanometers, and this source is delivering a power of P is equal to 3.3 into 10 power minus 3 watt. Okay, now what is he asking us to calculate? He is asking us to calculate the number of photons per second. Okay, for a time of 1 second, how many photons are emitting from the source? You have to calculate the number of photons. Okay, so now what did he give? He told that he gave power. So we can write, we know the formula for power as power P is equal to total energy emitted by the source by time. Okay, here time is 1 second. So that is T is 1 second. Now, and we took that n photons are emitted per second. The energy associated for each photon will be h nu. Okay, then the total energy will be, that is equal to ET, that is nh nu by 1. Okay, that is equal to n. Okay, for timing let me write nh nu by 1. Okay, now what are we supposed to calculate? We are supposed to calculate n. Okay, from here n can be written as n is equal to p by h nu, where nu is frequency, that can be written as c by lambda. And if I write c by lambda, what will I get? N is equal to p lambda by hc, where c is the velocity of light. Okay, now let us substitute. What did he give? He gave that the value of power as 3.3 into 10 power minus 3 watt, and wavelength as, how much did he give? Wavelength as 600 nanometers, that is 600 into 10 power minus 9 meters by h, Planck's constant. What did he give? 6.6 into 10 power minus 34 into c, that is speed of light, that is 3 into 10 power 8 meter per second. Okay, now so this will get cancelled 2 times, this will get cancelled by 200 times, this will get cancelled by 100 times. So 100 into 10 power minus 3 will be 10 power minus 1, 10 power minus 1 into 10 power minus 9 will be 10 power minus 10 by 10 power minus 34 into 10 power 8, that will be 10 power minus 8, that is 10 power minus 26, that is equal to 10 power 16 photons per second. Okay, so per second 10 power 16 photons are emitting from the source. Okay, of power 3.3 into 10 power minus 3 watt. Okay, generally we use bulbs of 60 watt. Okay, so now based upon this example, for 60 watt you can expect the number of photons emitting per second. It will be far greater than 10 power 16 photons per second. Okay, see, for 3.3 into 10 power minus 3 watt only you are getting 10 power 16 photons per second. Then for 60 watt you will get more photons per second. Okay, now let us move to our next question. Okay, so wait 1 minute. Before going to our next question, so an electromagnetic wave of wavelength lambda is incident on a photosensitive surface of negligible work function. If m mass is the photoelectron emitted from the surface, means from the surface has de Broglie wavelength lambda d, then so what did he give? He told that he asked us to find the relation between de Broglie wavelength lambda d and incident wavelength lambda. Okay, what did he give? Okay, he told that an electromagnetic wave of wavelength lambda is incident on a photosensitive surface and it has negligible work function. What does it mean? It means that the value of work function is almost nearly equal to 0. Okay, so when this electromagnetic wave of wavelength lambda fell on the photosensitive metal plate, what happened? Electron is emitted, and he told that the de Broglie wavelength for this electron is lambda d. He told us to calculate the relation between lambda d and lambda. Okay, so according to this photoelectric concept, we know that if Hc by lambda energy is incident on any photosensitive metal, that is Hc by lambda energy, okay, some part of energy will be used to free the electron, which is nothing but work function, plus rest of the energy will be used as kinetic energy. That is, this electron will come out with a kinetic energy, with this kinetic energy, okay. But he told that the value of work function is almost 0. That means Hc by lambda will be equal to Ke, okay, and Ke can be written as P square by 2m. Okay, so from this P square can be written as P square is equal to 2m Hc by lambda. Okay, now so this electron which came with an kinetic energy of this and momentum of this. Okay, so and regarding this we know that associated with every material particle there exists a wave called as matter wave, and the wavelength associated with that will called as de Broglie wavelength, and the relation between de Broglie wavelength and the momentum of the particle is lambda d is equal to h by p. Okay, so if I square on both sides, what will I get? Lambda d whole square is equal to h square by p square. Now p square can be written as, so according to this, p square can be written as 2m hc by lambda, that equal to h square whole divided by 2m hc by lambda. Okay, this h lambda. Okay, this h will get cancelled. This lambda will go up. Then what will I get? H by 2mc into lambda. That is lambda d square. That is lambda d square. Okay, but so now if I bring this entire thing towards this direction, what will I get? Lambda is equal to 2mc by h whole into lambda d square. Okay, so this is the relation between incident energy wavelength and de Broglie wavelength lambda d. So the option is second option, that is lambda is equal to 2mc by h into lambda d square. Okay, if you feel that this video is useful, kindly share to your friends. If you have any doubts or suggestions, you can comment me in the comment section. For more updates, kindly subscribe to my channel. Okay, the only thing that I expect from you is a single like, because your single like or the comment that you give will encourage me a lot, and it will be helpful for me to make more videos. Thank you.